Hello everyone, hope you're having an amazing day and welcome to a brand new video on this channel. If you're just starting out with R, or if you're an expert who wants to build on your existing R skills, then you should definitely subscribe to this channel. In part 2, we looked at the steps to combine, compare, sort and repeat vectors, and finally looked at the steps to create named vectors. In this part, we will learn to perform the commonly used mathematical operations that involve vectors. The operations we will look at include vector addition, subtraction, multiplication, division and exponents. We will also look at the approach to sum the elements within a vector, identify minimum and maximum, find dot product and magnitude of a vector, and finally look at the concept of vector recycling. I will use two vectors v1 with elements 1, 2 and 3 and v2 with elements 4, 5 and 6 to illustrate the operations. To add two vectors, simply type v1 plus v2 in the console. Here the first element of v1, that is 1, and the first element of v2, that is 4, are added to give 1 plus 4 is equal to 5. Similarly, the second element of v1, that is 2, and the second element of v2, that is 5, are added to give 2 plus 5 is equal to 7 and so on. To subtract the two vectors, simply type v1 minus v2. Here the first element of v1, that is 1, is subtracted from the first element of v2, that is 4, to output 1 minus 4 is equal to minus 3. Similarly, the second element of v1, that is 2, is subtracted from second element of v2, that is 5, to output 2 minus 5 is equal to minus 3 and so on. To multiply the two vectors, type v1 followed by the asterisk sign, then type v2 and press enter. As you can see, R outputs a vector where each element of v1 is multiplied with each element of v2. The same approach can be applied to divide the two vectors, but in this case we replace the asterisk sign with a forward slash as shown. These were some of the operations involving two vectors. Now let's look at operations on one vector alone. Say we want to sum the elements within a vector, then simply pass the vector, in our case v1, to the sum function and R will return the sum. This operation added the three numbers 1, 2 and 3 from v1 to give 1 plus 2 plus 3 is equal to 6. Similarly, we can find the mean or average of the elements within a vector by passing v1 to the mean function. Here, the sum of 1, 2 and 3, that is 6, is divided by the number of elements in v1, that is 3, to give 6 by 3 is equal to 2. The smallest and the largest element within a vector can be found using the min and max functions. As you can see, when I pass v1 to the min function, I get 1, since 1 is the smallest number in vector v1. Similarly, I get 3 when I pass v1 to max function, since 3 is the largest number inside v1. Note that the min and max function can also be applied to character vectors as well. As shown, when I pass the character vector with the first three English alphabets to the min function, we get the alphabet A, and similarly, when we pass the vector to the max function, we get the alphabet C. To square the vector, first type the vector, then enter the caret sign, then type 2 and press enter. We can use the same approach to cube a vector or raise it to any other power. Note here that when you are raising the vector to a fractional power, in order to find the square root or cube root, enclose the fraction in round brackets as shown. Otherwise, R would interpret as a separate division operation and will output an incorrect answer as shown. Before we get to the next topic, I wanted to urge all of you to provide your feedback in the comments below and support this learning initiative by subscribing, liking and sharing the videos. Next we will look at two complex vector operations. The first operation is dot product of two vectors. In dot product, we multiply the corresponding elements from the two vectors and sum them up to get a single scalar value. We use the operator that has an asterisk sign enclosed between two percentage signs to dot product two vectors. To find the dot product of our vectors v1 and v2, I can type v1 followed by the dot product operator, then v2, and then press enter and R will return the dot product as you see. I will also demonstrate calculating the dot product using an Excel spreadsheet. As you can see, the values of v1 are in column A and v2 in column B. As per the rules of dot product, we will first multiply the elements of both vectors. That is, multiply first element 1 with 4, 2 with 5 and 3 with 6 and then sum the result of these products. The next operation that we will look at is to find the magnitude of a vector. To find the magnitude, we sum the squares of all the elements from the vector and take the square root of the resulting sum. Let's do this in R. Step 1 will be to square the elements by raising the vector to a power of 2. Step 2 will be to sum the vector using the sum function. For this, I will nest the previous operation inside the sum function. I use the up arrow key on my keyboard to get the previous operation. Step 3 will be to take the square root by raising the operation from step 2 to 1/2. The final output 3.74 is the magnitude of the vector. The last topic that we will look at is called vector recycling. So at times, we might have two or more vectors where both the vectors are not of the same length. As you can see, I have two vectors x and y where x has length 3 and y has 5. Then the question arises as to how R would add or subtract these vectors, because from what we have learned previously, we need equal number of elements in both vectors in order to do any mathematical operation. The answer to this question lies in the concept of recycling, and what that means is that R automatically picks up the first element of the shorter vector and appends it to itself and keeps repeating the same steps until the two vectors are of equal length. When I try to add x and y, I get a resultant vector of length 5, which is also the length of y, our longest vector. So let's see what happened. The values in the first row are of vector x and that in the second row are of vector y, and the third row represents the output we got from R. So we will use some arithmetic to back calculate the missing values. First, in cell E1, we will subtract 8 from 7 to get 1, which by the way is also the value of the first element of x. Repeating the same step in cell E2 gives 2, which again by the way is the value of the second element of x. And what this tells us is that every time we have two unequal vectors, R will recycle values in the shorter vector to make the shorter vector equal to the longer vector. That's it for this video. Don't forget to subscribe and share this with your friends and colleagues who are interested in learning R. Good luck and happy learning.